So today we are going to continue the exercise. The question number 11.15. The question is like this. Explain why is orthonitrophenol is more acidic than orthomethoxyphenol. Which two compound we have to compare? Orthonitrophenol and orthomethoxyphenol. So first draw the structures of both. You can see this one is phenol. On ortho position we have nitro group, so it is orthonitrophenol. This one is also phenol. On ortho position we have methoxy group, so it is orthomethoxyphenol. Now nitro group, that is electron withdrawing group, and methoxy group, that is electron donating group. That is the difference between these two groups. So based on that group we can write that nitro group is electron withdrawing group, but methoxy group is electron donating group. Presence of electron withdrawing group makes phenol more acidic, and presence of electron donating group makes phenol less acidic. So orthomethoxyphenol is less acidic than orthonitrophenol. That is the reason. Okay. Again, nitro group is electron withdrawing group, and methoxy group, that is electron donating group. Presence of electron withdrawing group makes phenol more acidic, and presence of electron donating group makes phenol less acidic. Okay. The next question number 11.16. Explain how does the OH group attached to a carbon of benzene ring activate it towards electrophilic substitution reaction. Okay. So what we have to do here? Here on benzene ring we have OH group, alcohol group, that activates benzene ring towards electrophilic substitution. Electrophilic substitution means positive ion will attack on benzene. Okay. Again, positive ion will attack on benzene. Now we know this is the structure of phenol. In this structure total 3 double bonds are there in benzene ring. So 6 electrons are there from double bond. Now in addition to that we have oxygen here. Oxygen has 2 lone pairs of electrons, means total 4 non-bonding electrons are there. So plus 4 electrons on oxygen. So total 10 electrons we have on this structure, phenol structure. So attack of positive ion takes place here more easily. Okay. So that's what I have written here. In the structure, benzene ring has 3 double bond. OH group has 2 lone pair of electron on oxygen. So structure has total 10 electron density. So that makes easy positive ion attack. In this way, OH group activates benzene ring towards electrophilic substitution reaction. Okay. Again, what we have to do here? Total 3 double bonds are there. 6 electrons from that 3 double bond, and 4 electrons from oxygen, that are non-bonding electrons. So total 10 electron density we have on this structure, phenol structure. 10 electron density activates it towards positive ion, means electrophilic substitution reaction. The next question, give following reaction. First number, oxidation of propan-1-ol with alkaline KMnO4. Now oxidation is there and alkaline KMnO4 is reagent. Now this oxidizing agent is strong oxidizing agent. KMnO4 is strong oxidizing agent. So it will make carboxylic acid. Again, it will give carboxylic acid as product. So here you can see CH3, CH2, CH2OH means propan 1 all. When it reacts with KMnO4, alkaline KMnO4, it gives us carboxylic acid. Number of carbon remains as such. You can see 1, 2, 3 carbons. Number of carbon remains as such. Just instead of OH group, you have to write carboxylic acid group, propanoic acid. Okay. The next question, second one. Treating phenol with chloroform in presence of NaOH. Now, this is a name reaction. It is Riemann-Tiemann reaction. Okay. Treating of phenol with chloroform in presence of NaOH. That is Riemann-Tiemann reaction. So that reaction I have written here. When phenol reacts with NaOH and CHCl remains chloroform, it will give you this intermediate first. This one is base, this one is acid. So H2O will be removed here. H2O will be removed here and ONA takes place here. In addition to that, this is CHCl3. So on ortho position it will attach. So hydrogen from this ortho carbon and Cl from chloroform, that both will make HCl and give us this intermediate. Okay. When it reacts with NaOH, it will give you this compound. ONA remains as such. Instead of CHCl2, you have to write CHO aldehyde group. This one is our reaction, Riemann-Tiemann reaction. In Riemann-Tiemann reaction, one more step was there. That is, when it reacts with acid, what will it give? It will give OH and CHO. This one is called salicylaldehyde. That was the whole Riemann-Tiemann reaction. But here acid is not mentioned in the question. So this last step you don't have to write in this question. Okay. The next one, 11.19 number. 11.18 number, that is not in your course. So 11.19 number. Write mechanism of acid dehydration of ethanol to yield ethene. Okay. Previously we have discussed mechanism of hydration reaction. Means hydration means addition of H2O. Now here we have dehydration, means removal of H2O. For that we have to write mechanism. So first I have written the reaction. You can see this one is ethanol, CH3, CH2OH. When it reacts with concentrated H2SO4, or you can take concentrated H3PO3, H3PO4, that is concentrated acid. So what will happen here? OH group will be removed and from adjacent carbon one hydrogen will be removed here. OH and H, they both will combine together to form water molecule. You can see here H2O is removed and put a double bond between that two carbon. You can see we'll get ethene. Now what is the mechanism of that reaction? So first you can see the mechanism here. In first step, alcohol and H plus from acid. This H plus comes from acid, H2SO4. They come and oxygen has 4 non-bonding electrons here. Due to that, this H plus is attracted towards oxygen. So it will form this positive ion, CH3CH2, O positive ion and 2 hydrogens attached to it. This one is our positive ion. In second step, what will happen here? This H2O, whole H2O will be removed, taking these bond electrons. These electrons it will take. These bond electrons it will take, and so this positive ion will be removed here, and positive ion is shifted on carbon now because these bond electrons are belong to this carbon on and oxygen also. Now oxygen is taking both electron, so positive ion will be on carbon now. This removes as H2O, you can see here. Now in third step, what will happen here? This one is our CH3. So I have drawn the CH3 like this. Okay. Now hydrogen from this CH3 will be removed here, and it will be removed as H plus ion. Leaving the electron behind, it will be removed. So CH2 CH2, between them a double bond will be formed and H plus will be removed here. So this is the mechanism of dehydration reaction. Again, what was the first step? In first step, acid donates H plus to OH group. Acid donates H plus to OH group, and it will form a positive ion. Positive ion will be on oxygen. Now in second step, H2O molecule will be removed and positive ion comes on carbon. In third step, from adjacent carbon, hydrogen will be removed as positive ion, donating its electron to form a double bond. Okay.